All right, title of the notes today is going to be inscribed angles. And I'll start off with a definition. An inscribed angle is formed by two chords and has a vertex on the circle. Okay, so not in the circle. In the circle, like the center of the circle would be in the circle. On the circle is like on the circumference of the circle. So for example, this little picture. So I pick a point on the circle, call that point A, and draw two chords, a chord AB and chord AC. Then we say that angle BAC is an inscribed angle. If I have the center of the circle, say I make that D, then we'd say angle BDC is a what? Central angle. That's from yesterday, right? Okay, so now I've given you names for two types of angles. We got the inscribed angle and we got the central angle. Today our topic will be primarily about the inscribed angle. So first I want to look at how these are related to one another. Give me 1 second. It's freezing up on me. There we go. So let's start by a quick example here. Let's say we have a diameter as one of our chords, and draw another chord here. And let's make this a 100-degree arc here. Okay, and we'd like to know what this angle is here, so we'll call it X. So we had a homework problem kind of like this. I think it was what, number 3. And what helps is if you draw your central angle, because we know a relationship between our central angle and our arc measure. And so what is our central angle going to be here? What's that? 100 degrees. Okay. And so if we want to get to X, what would we do next? I'll put some letters here so we can describe it. So here's A, B, C, and D. So what else do we know before we get to angle X? Or what else can you find? Yeah. Yeah, because so those two form a linear pair, and so they're supplementary, and so we get 80 degrees. Yeah. We could also say this is 80 out here, right? Because that's half the circle, right? Yeah. Okay. Radii. We got that isosceles triangle. All right, so those are congruent, and all three add up to 180, so they both have to be 50. Okay, so you got 50 here, you got 50 there. So if I take, I'm just going to draw this same picture here. I just want to highlight a couple things without all the extras. So we have an inscribed angle, and we found that our inscribed angle is 50 degrees, and the arc that it intercepted was 100 degrees. So they're not going to be the same measure. like the central angle. The central angle matches our intercepted arc, and so the inscribed angle is going to be smaller. Is it always going to be 50 less, do you think? Or will it always be half? And in fact, in general, we're going to find that, and let's just jot that down here, the measure of an inscribed angle will always be half of the measure of its intercepted arc. And that is going to be the key thing that is going to just build our whole notes here. Everything we're going to do is going to build right off of that. That the measure of an inscribed angle will always be half the measure of its intercepted arc. So I'm going to start now with some examples and point out some key things in those examples. So in example 1, we're going to have a circle, center A, and a couple points on the circle. I'll put 3 points on the circle. A, B, C, or C, D, B, C, D. And kind of, I'm going to move B over. I don't want it to look like a diameter. Bless you. Okay, so I'm going to tell you that the measure of angle DCB is 95 degrees, and I want us to find the measure of angle DAB. Using what we just learned, that the measure of an inscribed angle will always be half the measure of its intercepted arc, and maybe applying what we've learned prior. Okay. Go ahead and find out what the answer is, and let me know when you have it. Everybody get it? 190. Yeah. So here's why. We have our angle here, which is what kind of angle? Inscribed. And our inscribed angle I gave you is 95. So then because of that, the arc measure from D to B is going to be double that, right? Which is 190 degrees. But then the arc measure is the same as the measure of the central angle, 190 degrees. Now it definitely doesn't look like 190, right? It looks less than 180, but the numbers, the way they work, is gonna be what we're following. So 190 is our answer. Okay, and what I want you to see here is that the measure of an inscribed angle is half the measure of the central angle. If they both intercept the same arc. Okay, number 2. Give you a circle, center A. I'm going to draw a diameter this time. B to C. We'll pick some point D on the circle, doesn't matter where. And draw this triangle. And I want you to find the measure of angle BDC given circle A. Go for it. And we're just thinking about inscribed angles. Inscribed angles, the measure of an inscribed angle is half the measure of its intercepted arc. That's all we're working with. And use that to help you solve this. Anybody got it? 90 degrees. And here's why. Some of you may feel like there's not enough info, but there is. Here's our inscribed angle. And if you look at the arc it intercepts, although I didn't tell you, you know what the measure is, right? Because we have a diameter, and diameter cuts the circle in half, so we know this is 180 degrees from B to C. And so the measure of our intercepted arc is half of that, which would be 90 degrees. There was a televised math competition with some of the top math people in the world, and they had this down to this one question here. And one of the questions they asked is, you got 30 seconds to draw as many right triangles as you can. They all have to be different right triangles, and they have to have perfect, angles. And they had a compass and they had a straight edge. And so the winner, what they did is they quickly used the compass to draw a circle. They knew what the center was. They used their straight edge to draw a nice diameter, and then they put a bunch of points on the circle, and then use their straight edge. There's a right triangle, perfect right triangle, because they knew what we just saw, that the measure of the intercepted arc is half, or the measure of the inscribed angle is half the measure of the intercepted arc. And so all these would be, and so they did a whole bunch of right triangles that way. And they won the competition that way, because using this fact. All right, so let's write down what we want to say here. If the inscribed angle has endpoints on a diameter, then it forms a right angle. Number 3. Okay, so I'm going to put 4 points on the circle. Doesn't matter where. And I'm going to tell you that the measure of angle CAD is 70 degrees. And I'd like you to find the measure of BDC. Oh, I'm sorry, I didn't mean that. I meant DBC. And think about inscribed angles. The measure of an inscribed angle is half the measure of its intercepted arc. It should be enough for you to solve this one. Answer? 70. Good, you're starting to see it. The big thing is seeing things. And if you don't see it, I'll help you see it, okay? So CAD, I'm going to highlight. CAD is this right here. You guys see the inscribed angle? Right, where A is where the angle is happening. And so we know that that is 70 degrees. So that means that CD is going to be 140. So I can put 140 out here, and that goes from C to D. And then if we look at the other angle, it's also an inscribed angle, and it also intercepts the same arc. So it's going to be half of 140, which is also 70. Okay. Are these two? What can you say about these two triangles? They're congruent. Why? Why are they congruent? I heard congruent first. So why are they congruent? So obviously they have vertical angles, right? These are congruent to each other. Can we say that this angle is congruent to this angle? Why? Yeah, if these two are the same, the third angle theorem. Or you could say that they both intercept the same arc. They both intercept arc AB, right? So anyway, so can we say they're congruent by angle, angle, angle? Yeah, that's not something we studied, huh? So they're not congruent, but they are, and I heard some people say it, they are similar to each other. And whenever you draw, cross two chords and draw triangles like this, they'll always be similar because of that fact. So here, what I wanted you to see is that two inscribed angles that share the same intercepted arc will always be congruent. All right, next we're going to have to remember a little bit about quadrilaterals. We did a whole unit on them. So quadrilateral means you got four sides, right? And it could look like anything, right? So can you tell me anything about all quadrilaterals out there? Okay, so if we add up all 4 interior angles, we get 360 degrees. Okay, kind of like a circle, huh? What else is true about all quadrilaterals? They all have 4 sides, yes. Can we say that 2 angles have to add up to 180? Which 2 angles have to add to 180? Which ones? Same set. So these 2 on every quadrilateral, or just some? So can we think of some where? So could I have like make them both really small? So this right here and this right here doesn't add up to 180, and then connect these. You could, huh? But remember, we had parallelograms. If we have a parallelogram, then we can say more stuff about it. We could say, okay, yeah, these 2 have to add up to 180 because you have parallel now, cut by transversal. So don't confuse what we learned about parallelograms with what we're going to do now. So if we have a circle and draw any quadrilateral in the circle, so it does not have to be a parallelogram, okay? Anything. So it doesn't matter where I put those 4 points. It could be something weird like this, okay? So you connect them with chords. And by the way, if I say it's a quadrilateral A, B, C, D, say that's the name of the quadrilateral, make sure you follow the order. So once you start a direction, you have to keep going the direction. You have to go like A. If I choose to make this one B, I've shown the order. I can't make this one C over here. I have to keep going around the circle. This would be C, and then this would have to be D. Order is going to matter, and I'm telling you that for one of the problems that you're going to have on the homework. Okay. So you go around, there it is. And I'm going to tell you that the measure of angle BAC not BAC, BAD, the bad angle. Okay. That one looks, I don't know, what does it look like? Kind of like 80 degrees maybe? And I would like you to find the measure of angle BCD. Remember, everything we're doing is dealing with intercepted or inscribed angles and intercepted arcs. So don't think about quadrilaterals, even though we have one here. Think more about inscribed angles to help you with it. Measure of BAD is 80 degrees. Find the measure of BCD. Right? Anybody get it? Yeah. 80 degrees? No. 150? No. Oh, no. So let's put down what we know. So BAD. Okay. Do you guys see the inscribed angle? Okay. So the inscribed angle is 80 degrees. So this is 80 here, and so that tells me that the arc measure from B all the way around to D is what? 160. It also tells me that the arc measure from B this way to D is going to be how much? 200, because that's a full circle, right? 160 plus 200 is going to be 360. Now let's look at what we're after. BCD. Do you see another inscribed angle? See where we're headed? What's the answer going to be? 100. There we go. Because that's half of the 200, and so we get 100. And it turns out that, so these are what we would call opposite angles, right? It turns out that if you have any quadrilateral in a circle, inscribed is what we say, inscribed in a circle, that the opposite angles will always add up to 180 because they're half of the full circle, right? Full circle is 180, 360, and half of the 360 is 180. So let's jot that down because that's another important thing to know. Opposite angles in a inscribed quadrilateral are supplementary, which means they add up to 180 degrees. Okay. So those four examples show you four different applications of the inscribed angles, and those are the four things that you need to know. I'm going to end with two more, and I'm just going to use these kind of properties, but I'm going to now include solving for x and some factoring stuff because we need a little more practice with the factoring. Okay, so two more examples here, a little more application types. So number 5, we've got a circle. I'm going to put a quadrilateral inside of it. A, B, C, D. I'm going to tell you that the measure of angle BAD, there's that bad angle again, is going to be x squared plus x degrees. And that the measure of angle BCD is going to be 2x plus 170 degrees. And I would like you to solve for x. Try it out. Let me set this one up. Can I set them equal to each other? Can I say x squared plus x is equal to 2x plus 170? Maybe, maybe not. Let's look. So I give you BAD, so this angle here, and I give you BCD, this angle opposite. Are opposite angles always congruent in a circle? No, that's not what we wrote. What did we write? Opposite angles are supplementary. They add up to 180. So what you have to do is you have to add them together. So the x squared plus x added together with the 2x plus 170. When you add them together, you know it's going to add up to 180. So it's a little different setup, but it uses the principle that we just learned here. Now, although I have parentheses around here, doesn't mean you multiply. There's a plus sign in between, so you could just drop the parentheses and means the same thing. Don't let that throw you off. And then x squared, we have x plus 2x is 3x If I subtract 180 from both sides, I get minus 10 equals 0. So this is where we want to be. If we have a quadratic, set it equal to 0 and try to factor it. Anybody get this far? Did you factor it? You got the answer? Good. So when we factor it, we're looking for two numbers that multiply to 10, add to 3. What are they? 5 and negative 2. So we got x squared plus 5x minus 2x minus 10 is equal to 0. Keep factoring by grouping. And so we end up with x plus 5 times x minus 2. And then we set them equal to 0 and solve. We get two answers, negative 5 and positive 2. And then we have to decide, do we keep both of them? Do we get rid of one? What do you think? And how do you know? Well, it's okay to have a positive or negative answer. As long as if you were to plug it back into the problem, it doesn't give you something that doesn't make sense. Like you can't have a negative angle. You can't have a negative side length. So the question is, if I were to plug a negative 5 back into one of those expressions for the angle, would it make it a negative angle or something that wouldn't make sense? No, it'd work out. It'd still get a positive angle. So we can actually keep both of them in this case. Okay? So two possible answers that would make this scenario work. All right, last problem I want to give you for your notes. See if you can get this one. Number 6. Okay, so we have a circle with center A and pick 3 points on that circle, B, C, and D. And I'm going to tell you that the measure of angle CBD is 40x cubed. And the measure of angle CAD is 10. Doesn't look like it, but let's imagine it's 10 degrees. And I'd like you to solve for x. All right, so setting this up, you're going to say that the inscribed angle, the 40x to the third, is going to be half the central angle, 10. That's what we saw in number 1 on our notes. So you end up with 40x cubed is 5. I want you to solve by factoring, so you set it equal to 0. And then factor. Now there's different types of factoring to choose from. First type of factoring you want to think about is a GCF, something that you can divide both terms by. And in this case, I can divide them both by 5. I'm left with a 8x cubed minus 1. And then I have a cube, so I'm thinking, well, is that a difference of 2 cubes or a sum of 2 cubes? It's a difference. And 8x cubed is a perfect cube, and so is 1. And so I can continue to factor. We got 5 times 2x minus 1. So I got that from taking the cube root of 8x cubed to give me the 2x. And the cube root of 1 is going to be 1. And then my third factor is going to be what? 2x times 2x, which is 4x squared, plus 2x plus 1 equals 0. So now I have 3 factors. My last factor is not going to give me any real solution. I'm not going to pursue that one. My middle factor, I could take 2x minus 1, set that equal to 0, and solve. I get 2x equals 1, so x is 1/2. And how about my first factor? There's no variable, right? So I can't solve for anything. So if there's no variable, you're going to ignore it. So the only one that really applied is the middle factor. And we got 1/2. And then you just check, make sure, does that make sense? Could we use it? And it will work out. So good. Okay. All right, so I'm going to stop there with the notes, and I'm going to give you a lot of time to work on the homework. Time as you work through it, check with the people that are sitting around you. Ask me if you guys can't figure something out. Use this time to try to get this down, okay?